Okay, so I'm going to show you how to calculate molar mass and how to do some basic mole problems using molar mass. Molar mass allows you to be able to tell how many grams you're going to have in your calculations. So to start off, you need to know the atomic mass of each of the elements that are going to be present in the molecules or the formula units that you're working with. Remember, molecules refers to elements that are covalently bonded, and formula units are going to be dealing with those that are ionically bonded. So if you don't remember, which you should, but right here I've got hydrogen highlighted on my periodic table, and it has an atomic mass of 1.008. So the molar mass is really, really easy to calculate. And I'll get to the PowerPoint. But it's pretty straightforward. To find the molar mass, the steps are listed on the right here. First thing you need to do is list all the elements that you're working with. So right here, this is water. Water is covalently bonded, so it is a molecule. So there's hydrogen and there's oxygen. And there are specifically 2 hydrogens and 1 oxygen. Right? So hydrogen has an atomic mass of 1.008, and oxygen, there's 1 of them, has an atomic mass of 15.99. So 2 times 1.008 is going to be 2.016. 2.016, and you're going to add that to 15.99. So 2.016 plus 15.99 is going to be a total molar mass of 18.006. What I want you to think of is the units are grams per mole. So for 1 mole of water, the molecule water, you're going to have 18.006 grams in 1 mole of water. Let's try another one. So if you look, that's all written out right nicely. Then you've got nitrogen and hydrogen. So if I were to do this, nitrogen, there's my elements. I have nitrogen and I have hydrogen. I only have 1 nitrogen and I have 3 hydrogens. Sometimes I just do it really quick. Hydrogen has an atomic mass of 1, so I'm just going to say 1. And nitrogen has an atomic mass of, if you look at it, let's look at the thing, let's look at the P table. Let's look. Nitrogen, if you're looking, has a mass of 14. So, to do it quickly, so you've got nitrogen is 14, about 0.007, and hydrogen, there's 3 of them. I want you to be specific, but I'm doing this quickly. So 3 times 1 is 3. You've got 14. So 14 plus 3 is 17. So about you have a molar mass of 17 for the molecule NH3. You know that's covalently bonded because both of those are nonmetals. So this is 17 grams for every mole of NH3 that you have. Now to actually use that is the weird one. I'm going to do a little bit of mole practice. So if you want to know how many moles are in 25 grams of water, here's how you would do it. So how many moles are in 25 grams of water? And this is where you use what I taught you at the very beginning. You're starting off with 25 grams of water. And I want to know how many moles that is. Just like we were converting before, we calculated water to be 18.006 grams for every 1 mole. The grams cancel, so then I would be left with 25 divided by 18.006, and I wind up with 25 divided by 18.006, and I'm going to wind up with 1.39 moles and those 25 grams. So there's 1.39 moles of water in that 25 grams. So it's over a mole. It's a mole and a third, essentially. Let's practice another one. How many grams are in 4.5 moles? So I want to know how many grams are in 4.5 moles of Li2O. Let's see. We're going to know the molar mass first. So lithium is 6.94, and you've got 2 of those, and oxygen is 15.99. So, going back, so there's lithium, and there's 2 of them. 2 times 6.94. Boy, this is not writing well. So I got 13.88. And then you've got oxygen, which is one of them, at 15 point, why is this not writing? 99. So when you add those together, 15.99, you get 29.87 grams per mole. And that's the number you need in order to calculate. So you go back to 29.87 grams per mole. If you go back to our original problem, right here, I want to know how many grams are in 4.5 moles. So I start off with moles, and I need to convert to grams. So you always start off with what the problem asks you for, which is 4.5 moles. And I need to go to grams. So for every 1 mole of Li2O, I'm going to wind up with 29.87. So then I would just multiply 4.5 times 29.87, and I'm going to wind up with 134.4. This is grams, so the moles cancel. So it's going to be 134.4 grams of this stuff for those 4.5 moles. So it's the same thing that we did at the beginning of the year, it's just applying it to moles. Anyways, what I'd like you to do right now, while I'm not here, is please turn to page 338 in your book, and you're going to do problems 51 and 52 and 58 through 65 on a separate sheet of paper and turn it in. Also remember to turn in your notebook.